All right, welcome back. And as promised, we now have an example of using regression with actual data. So the data that we're going to analyze comes from onlinestatbook.com, a great free resource. And this is going to be an example where we want to predict university grades. Well, if you remember, whatever variable we're trying to predict is our dependent variable. And so we're going to say that our dependent variable is university grades measured as a grade point average. In other words, a 4.0 means that you got straight A's, the highest grade. A 3.0 means you got all B's or a B on average at least. A 2.0 would mean you got all C's, or is what you would get if you got all C's, and so on and so forth. So that is our dependent variable, the grade point average that a university student makes while at the university. The independent variable is going to be the grades, the GPA that same student got in high school, and measured in the same way. And our question is, how much better do we expect a student to do at university in terms of their GPA if they scored well on their GPA in high school, for example? That's the kind of question that we can answer with regression. So, first of all, you can see that I have some Stata code here on the slides. And earlier, what I've done is I've copied and pasted this code as well as some code from the next a slide or two later into this do file. And you might not have seen these triple slashes before. What they do is they just tell Stata, I'm running out of room. I'm going to finish this command on the next line, but that's a little bit hard to read. So I'm just going to go ahead and delete these slashes and bring this option onto a single line. We just didn't have enough room on the slides, but it's easier to read if we just put this all on one line. So here, this command is going to read in the data set from this website. And then we have the first couple commands here. I'm going to go ahead and execute those and go over to Stata to see our output. And you can see it's still working on the graph. Here's our scatter plot, though. So let's first look at just what is the correlation between university GPA and high school GPA. And you can see that it's this number right here, a correlation of 0.78. So a pretty strong positive correlation, much closer to 1 than to 0. So that's why I say it's a pretty strong correlation. You can see here, if we were to draw a straight line through this, we would want to draw an upward sloping line from left to right, which is our clue that it's a positive correlation and that the data does not perfectly by any means adhere to a straight line, but it's decently close. So that's why we have a fairly strong correlation here. And of course, we have on the x-axis, high school GPA, our independent variable, and on the y-axis or the vertical axis, our dependent variable, the university GPA. So if we come back to our slides, you can see a little bit of interpretation of that correlation. And the note that we still haven't run a regression. So here's the code to actually run the regression. Let's go ahead and run these next few lines of code. So we're going to get another graph is what this second line is doing. And you can see right here that it's added, Stata has added a drawing, a rendering of the regression line to this figure. But let's go to the main output in Stata. And this is the kind of output that you typically get when you run a regression. This is maybe much harder to interpret at first than that graph. But this is where we're going to use those three S's that we learned about, the sign, size, and significance. Sorry, I mentioned that in the wrong order. It's significance, and then sign, and then size. That's generally the order in which we want to interpret those S's. So first of all, significance. Um, all of our analysis is going to focus on this row of the output. And what we need to look at for significance is the p-value. Right here, we can see our p-value under this column, p greater than absolute value of t. That's a little bit of a funny heading, but that indicates that this is the column that we need to look at for our p-value. We're wondering, is the p-value less than 0.05 as is shown on that slide with the cheat sheet, which I'm not going to show you right now, but you can go check yourself. It says we want to compare, is it greater than or less than 0.05? And in this case, we see that this rounds to 0, right? It's definitely less than 0.05. Therefore, that means that this independent variable is statistically significant. There is some sort of meaningful relationship between our independent and our dependent variable. So that means it makes sense to proceed to thinking about the sign and the size. For sign and size, we're going to look at this value right here under the column coefficient. first thing we can see is that there's no negative sign here. That means that this is a positive sign. The sign of this coefficient is positive. That means that a higher high school GPA predicts a higher university GPA. And finally, what is the size of this? Well, the rule of thumb that you just kind of have to memorize is that this is showing how much we expect the dependent variable to increase if the independent variable goes up by 1 unit. In other words, if high school GPA goes up by 1, how is high school GPA measured, right? 4.0 is the largest value you can have. 3.0 means you got all Bs or on average got all Bs. 2.0 means you got all Cs or on average got all Cs. So going up from, for example, all C's to all B's predicts that your university GPA will go up by zero point 0.7, right? In other words, not a full letter grade, but approaching it, right? So if a student who did a whole letter grade better in high school is expected to do 7/10ths of a letter grade better in university. That's the basic interpretation of these variables or of this output. So it's probably going to take you some practice to really get used to interpreting regression output, the significant sign and size. But there's one example to get you started. And of course, practice makes perfect. So there will be more examples that you'll want to go through in order to master this. But at least now you have an overview of what that process looks like. A couple more notes about regression. Linear regression is a powerful tool. So, this is just a very brief introduction. We could spend a whole semester talking about regression, just introducing it today. There's some more examples in the appendix that are going to help to flesh out the details if you want more details, but we're going to ignore those for now. And I want to conclude just by offering a couple of comparison points of correlation versus regression. If you're enrolled in my course, this is going to be a good slide to review when it comes to midterm time, because I might ask about differences between correlation and regression. But correlation coefficients and regression coefficients are both going to tell us something about the relationship or the association between two variables. But they're also going to be interpreted somewhat differently. Correlation coefficient is basically going to tell us how closely the data falls to that straight line. In other words, if we're looking at a scatter plot, does all the data cluster really closely along a straight line or not? On the other hand, a regression coefficient is going to tell us what that line looks like. Is it super steep? Is it close to a flat line? How steep is that line? Regression can tell us that. A correlation coefficient can't. Both a correlation coefficient and a regression coefficient are going to allow us to draw conclusions about whether two variables are associated with one another. And another thing to know is that anytime you have a positive correlation, you're also going to see a positive regression slope. Anytime you have a negative correlation coefficient, you're going to have a negative regression slope. So the sign of a correlation coefficient and a regression coefficient are always going to be the same. They're always going to have the same sign. But correlation coefficients are always between -1 and 1. Regression coefficients, you can have a value like 5 or -20, right? They're not always going to be between -1 and 1. And they're telling us something different, what the line looks like, how steep it is, as opposed to how closely the data falls along that line. So, there's more in the appendix if you want to explore those slides on your own, but that's where we're going to leave things for the videos today. Like I said, this is just a brief overview of studying associations. There's a lot more to say, and there's going to be more on it in future lectures, but this just kind of introduces the main tools that we're going to use to study how two variables are related, whether those are two qualitative variables, two quantitative variables, or one quantitative variable and one qualitative variable. Now at least you have an overview. All right, see you next time.